Okay, so let's just fix this up. So this was 4x. So we got x squared plus 4. I'm hoping that shows up okay. Let me just go over this again so it shows up good on the video. So x squared plus 4x. Here's the x squared, here's the 4x, and we still have that plus 2. So that is what we get if we factor it. Now, let's look for our key values. When is f double prime of x equal to 0? And when is f double prime of x undefined? So let's start with equaling 0. F double prime of x is equal to 0 when? Well, when either e to the x is equal to 0 or this quadratic is equal to 0. Well, e to the x is an exponential function. They're never equal to 0. The x-axis is a horizontal asymptote. They're always positive. They're always above the x-axis. So the only way f double prime of x is going to be 0 is if this quadratic is equal to 0. So you might try to factor this. So if you wanted to factor this, you'd have to look for two numbers that add to 4 and multiply to 2. Good luck, it won't happen. You're not going to be able to factor this. So how are you going to find the values that make this quadratic equal to 0? Well, the answer is in the name, right? Use the quadratic formula. And you can do that. And I'm going to skip those details, but because I know you guys can do the quadratic formula, just set this equal to 0 and use the quadratic formula. This is going to be when x is equal to -2 plus or minus the square root of 2. Those are going to be the two values that make the second derivative equal to 0. And again, find those values by carefully applying the quadratic formula and setting this quadratic equal to 0. And these are the values you'll get. What about the values of x that make f double prime of x undefined, if there are any? Let's check. Well, e to the x, that's defined everywhere. Domain of e to the x is all real numbers. X squared plus 4x plus 2, that's a polynomial. It's defined everywhere, so this will never happen. F double prime of x will never be undefined. All right, so that's all we need to set up our second derivative table, which is going to be a little bit trickier this time because we have these nasty values here, -2 plus or minus the square root of 2. Those are not particularly nice values to work with compared to some of the ones we've been fortunate enough with before, but nonetheless, this is the hand we were dealt for this problem, so we have to work with it. So we're going to have one row for f double prime and one row for f. Then we'll have one slice for -2 minus root 2, because that's the lesser of the two values. And then the other value, we've got -2 plus root 2. Okay, so we got to choose sample points in between those values. Well, start with the easier one. Something that's between -2 minus root 2 and -2 plus root 2. Well, this is like -2 minus something and -2 plus something. So one number that's guaranteed to be in between them is -2, and it's fairly easy to work with. So that one's actually good. Now over here we need a number that's less than -2 minus the square root of 2. Well, the square root of 2 is, this is where decimal approximations are helpful. The square root of 2 is approximately 1.4 something, right? So this is like -2 minus 1.4 something. So if you want to be guaranteed to get something that's less than that and is going to be a nice number, rather than subtracting 1.4, why don't we just subtract 2 and go -2 minus 2? So that'll be like -4. So that'll be a good sample point over there. That'll be fairly easy to plug in. And then over here, we want a negative value, or not a negative value, a value that's greater than this value over here, something greater than -2 plus the square root of 2. And again, this adds approximately 1.4. How about we just add 2? That's larger than the square root of 2. So if you go -2 plus 2, you'll get something that's guaranteed to be a little bit on this side of -2 plus root 2. And if you do that, if you go -2 plus 2, you're going to get 0. So those 3 points need to be plugged into f double prime of x. So let's work them out down here. Let's just roll up our sleeves and get to work. So f double prime of -4. All we care about is whether it's positive or negative. We don't need the exact value. So this is going to be e to the -4, right? Because it's e to the x first of all. So plug in -4 for x. You're going to get e to the -4 times, this will be -4 squared watch your brackets, plus 4 times negative 4, so plus 4 times negative 4, and then plus 2 afterwards, which looks a bit messy, but we can work with this. This is going to be e to the negative 4, and then in the brackets we'll have 16, because negative 4 squared is 16. Here you have 4 times negative 4. That's going to be negative 16, and then you're plus 2. So is this enough? Well, e to the power of anything is positive, right? Remember the natural exponential function, and in fact every exponential function is always above the x-axis. So it doesn't matter that this is a negative 4. It doesn't matter what number was up here. E to the anything is greater than 0. So this is just a positive number. It's all going to come down to what's inside the brackets, and the two 16s cancel and you're just left with positive 2. So you've got a positive times a positive, which is a positive. So that means this region, the function is going to be concave up for all the values of x less than negative 2 minus root 2. Okay, and then, well, let's plug in our next point. F double prime of negative 2. Well, we're going to have e to the negative 2 times negative 2 squared plus 4 times negative 2 plus 2. Okay, so what's that going to work out to be? We'll have e to the negative 2. Negative 2 squared is 4. This is 4 times negative 2. That's going to be 4 minus 8 plus 2. So 4 minus 8 is negative 4. Add 2 and you're going to get negative 2. So these brackets are negative 2. And this is a positive number. So you've got a positive number times negative 2. The result is going to be negative. So that means between these two values, negative 2 minus root 2 and negative 2 plus root 2, the function f is concave down. And then lastly now, our last value of 0, plug in 0, and we're going to get what? Well, plug a 0 in here, we'll have e to the 0, then 0 squared plus 4 times 0 plus 2. Okay, so that's going to be positive. E to the 0 is positive 1, but doesn't matter, it's just positive. That's all we care about. 0 squared plus 4 times 0, this is just 0, but then plus 2. So we got a positive and then positive 2. So this is actually going to be positive as well, because these just disappear. So you've got 1 times 0 plus 2. So it's going to work out to exactly 2, but the important part is it's positive. So we can say that that is how we can finish our table. Now, are there going to be any inflection points? Well, yes, right? There's a concavity change here, and there's a concavity change here. So there's going to be inflection points with these as the x values. So how do we get their y values? Well, we're going to plug them into the original function, right? So let's do that now. So f of negative 2 minus root 2, almost off the screen, I better move it up a bit. So plugging this value into the function, so we're going to get negative 2 minus root 2 squared times e to the negative 2 minus root 2. So what is that value? Who cares? It's written down, right? You're not going to do any better than that. I mean, what are you going to do, foil this out? Is that going to help anything? No, that's not going to help anything. I mean, you could foil this out and then expand it. You'd have 3 terms. Every one of them would have a common factor of this, and you'd have it would just be, I didn't want to think about it. What's the point? There's nothing wrong with just leaving it like this. It's nasty like this too, but it's an awful number, right? Whatever it is, it's an awful number. If you want a decimal approximation, go ahead and plug it into your calculator, but that's not going to be particularly useful here. So all we need to know is that this is the y-coordinate of the inflection point that has an x-coordinate of negative 2 minus root 2. And we'll do the same thing for this point. We can work out f of negative 2 plus root 2, which is going to give us negative 2 plus root 2 times e to the negative 2 plus root 2. And I should have a squared on there. So those will be the y-coordinates of the inflection points. We've got our concavity and the x-coordinates of the inflection points on this table. We've got all the information we need. We're ready to summarize it. And we're out of space here, so we'll do that on the next page.